Hello everyone and welcome to Net 206. This session is all about AWS Transit Gateway Connect and how you can connect your network to the AWS Cloud using it. My name's Matt Johnson. I'm a solution architect in the UK public sector team, and I'm with you for the next 30 minutes to talk to you about this new service. In terms of what we'll be covering today, we'll give a little bit of background in terms of what we mean by hybrid connectivity and how we've done it in the past. We'll look at existing approaches, and then we'll talk about Transit Gateway Connect, how we're going to use this new service to improve our connectivity, how we can use it to integrate SD-WAN services, and how we can deploy it. We'll do a deployment walkthrough. We'll look at a couple of details around implementation. We'll understand the launch partners this service is going to launch with, and then we'll wrap up with a summary. Before we start, some definitions and acronyms we'd like to use throughout the session. So SD-WAN, software-defined wide area network. This is the idea that you can connect a wide area and a local area network using code and rather than physical appliances. Amazon VPC, Amazon Virtual Private Cloud. This is a way of carving out a segment of the AWS network for your use. AWS Transit Gateway is our cloud scale router that we introduced a couple of years ago and will be a part of this service. GRE stands for Generic Routing and Encapsulation. This is a protocol that allows us to establish a tunnel between 2 points and is to exchange traffic across it. BGP, Border Gateway Protocol. This is how we're going to define our and share routes and share route information between 2 ends of the tunnel. CIDR or CIDR is our classless interdomain routing. This defines the IP blocks and routing information, IP blocks that will be used for the routing. And lastly, points of presence. This is in reference to our direct connect capabilities. So I'll start with some common requests we hear from customers around hybrid connectivity. And in essence, it boils down to 3 things. First, customers are really keen to use AWS as their network hub for their global network. So that's for integrating on-premises SD-WAN hubs or on-premises infrastructure with AWS. And they really want the ability to do this easily, to be able to manage these disparate networks from a straightforward process or straightforward system, and simplify the provisioning process to decrease the operational burden and improve the speed of deployment for things like SD-WAN hubs and branch connectivity. So in the past, we've used a pattern that we've called Transit VPC. This has been quite complex to set up, manage, and scale, and was typically limited by the throughput available on the SD-WAN appliances because it was an EC2-based service. So as we look at the diagram, we can see that we have those third-party appliances in the appliance VPC. We have it connected to a couple of branch offices and a corporate SD-WAN hub. That connectivity is typically over an SD-WAN overlay. And then in order to scale that appliance VPC, the instances in there connect to those spoke VPCs, those application VPCs, using site-to-site VPN. And so this is required to enable transitive routing, but there are issues around costs, around performance, around throughput. And it's something that we knew that we had to have a better solution for. So a couple of years ago, we introduced AWS Transit Gateway. This was, as I mentioned before, our cloud scale router. And if we look at how it improves our previous architecture, it enables us to replace those site-to-site VPNs between the hub VPC and those app VPCs with this cloud-based router, this transit gateway. This means that we can scale to thousands of VPCs very quickly, very easily, without the need for the complex site-to-site VPNs. However, we still need that site-to-site VPN between that hub VPC and the transit gateway, because this is the bit that shares the routing information back to the branch networks and back to the data center. And so we've now introduced a new service, AWS Transit Gateway Connect. And this is a capability built onto Transit Gateway that simplifies that branch connectivity by natively integrating those SD-WAN virtual hubs, those EC2 appliances, into Transit Gateway. So let's look at how this works. So in this first scenario, which would be a typical SD-WAN scenario, what we've done is we've used the new Transit Gateway Connect capability to replace that site-to-site VPN between the hub VPC and the Transit Gateway with the Connect attachment. This means that we can do dynamic routing and we can share that route information between the SD-WAN hub, the appliances in there, and the transit gateway, so reducing that routing complexity. We can continue to integrate with our on-premises environment, so the branch networks and the corporate SD-WAN, and the transit gateway continues to handle the routing to the spoke VPCs, those app VPCs. So this solution improves the scalability and throughput and helps reduce the complexity. So that's the first scenario. We also have a sort of another option for Transit Gateway Connect, where we look to use the Transit Gateway Connect capability over a direct connect link straight back to a corporate data center. So you might choose to do this if you want to replace a site-to-site VPN or another type of connectivity with this way of connecting into Transit Gateway. It reduces costs and is easier to scale. One thing to note, though, is it does have no encryption, layer 3 encryption built in. So it would be expected to use application layer encryption if you needed encryption for this. Some of the key capabilities of Transit Gateway Connect. Firstly, that native SD-WAN integration. So better native integration with customers' SD-WAN. And we'll talk about how some partners have done this to help improve the customer flow. Simplified management and orchestration, so simple provisioning as well as advanced programmability. So we use API, we can have event-driven architecture to automate the deployment of these solutions. It improves the security and compliance. So this is a key one for some of our customers who operate in regulated environments. By removing that need for site-to-site VPN, we've removed the need for having public IP addresses and help reduce the attack surface area. And lastly, because it builds on top of Transit Gateway, it benefits from the scalability and performance that Transit Gateway natively offers. So what we'll do now is have a quick look at the components that make up Transit Gateway Connect. So Transit Gateway Connect starts with a transit gateway. That gateway can be one that you already have in your VPC, in your architecture, or you can create a new one. So in this example, we have a transit gateway with 2 VPCs already attached and some application instances. And you notice those VPCs are attached using a VPC attachment. So the first stage in deploying Transit Gateway Connect is to create a VPC that will host our SD-WAN appliances. So we've called it a Connect VPC here, but sometimes you'll see it referred to as an Edge VPC or a Hub VPC. It means the same thing. It's where we're going to host our EC2 appliances, our SD-WAN hubs. Again, this Connect VPC is attached using a VPC attachment. So what we then have is a Connect attachment. And a transit gateway, this is a new transit gateway attachment type that builds on top of an existing transit gateway attachment. So either VPC or, as we've added to this diagram now, a direct connect attachment. And then that allows our network virtual appliances to connect into Transit Gateway. But for the rest of this slide, we'll remove the direct connect component and we'll just focus on the connectivity for the VPC. So here you can see we've established a connect attachment over the VPC attachment into the Transit Gateway. What we're then able to do is to spin up a network virtual appliance. So this will be an EC2 instance, typically running as an SD-WAN hub, although it could be a separate type of network router, running on EC2 in that Connect VPC. It will have an IP address on that Connect VPC. It may well have connectivity out to your SD-WAN edge over VPN or an SD-WAN overlay. But what will happen then is we are able to create what we call a Connect peer. This Connect peer is a GRE tunnel, which is established between the network virtual appliance in the Connect VPC and the Transit Gateway itself. And once that GRE tunnel is established, we can exchange routing information using BGP. And now we can integrate Transit Gateway into our SD-WAN architecture. So those are the components that make it up. What we'll do now is go through a quick deployment walkthrough. To start, some prerequisites. So we mentioned that it builds on top of Transit Gateway. Transit Gateway now has the ability to have CIDR blocks assigned to it. So these can be blocks of either IPv4 or IPv6 or both. But they must be at least a /24 for IPv4 or a /64 for IPv6. What we'll then do is we'll be thinking about creating those connect peers, so those GRE tunnels between our appliance and between the Transit Gateway. And the way we do this is we take an address from that Transit Gateway CIDR block, and we'll call that the transit gateway address. We take an IP address for the network virtual appliance, which we'll talk about in a second. And then together that establishes a combination for the connect peer that is unique across the transit gateway. So the final piece is the network virtual appliance. So this is the virtual appliance, the EC2 appliance that will configure and establish the GRE tunnel from itself into the transit gateway. And we'll also configure and exchange the BGP routing information so it can share routes with the transit gateway. So we'll walk through the different stages of doing this and the features you need to include. So first, as mentioned before, we need to attach the Connect VPC to the transit gateway. And we do this using a VPC attachment as we would any other type of VPC attachment. We then create a Connect attachment on the transit gateway using the VPC attachment as the transport. So again, the Connect attachment runs over the top of the VPC attachment. On the transit gateway itself, we configure a transit gateway CIDR block, which will be used for the peer IP side of the Connect peer connection. So in this case, we've added a /24 IPv4 block, 10.10.10.0/24. So that's been configured onto that transit gateway. We then have to configure the VPC route table in the Connect VPC to provide instances that are launched within that Connect VPC a route to that CIDR block. And so that will configure a route for the 10/24 network to our transit gateway attachment. The next thing we do is we'll launch a network virtual appliance. So this could be our SD-WAN hub or other network router. And that will launch, that will get an IP address from that VPC. So in this case, it's gained the address 172.16.0.10. And the final piece of the puzzle is that we then create a Connect peer, which is the GRE tunnel, between the network virtual appliance and the transit gateway Connect. And to do that, we take an IP address from the CIDR block that we assigned. So in this case, 10.10.10.1. The peer address, 172.16.0.10. We give an inside CIDR block, which is used for the BGP exchange of information, and a BGP peer ASN number. So together, those are the components that we need to use to deploy Transit Gateway Connect. Let's have a look at some screenshots and how this appears in the console. So this is some screenshots from the AWS console. On the left, at the top, what we see is the option to create a new transit gateway. So as you would have seen before, nothing's changed except for the addition of a section at the bottom, which allows you to define your transit gateway CIDR blocks. You can click to add more than one, and again, you can choose whether those are IPv4 or IPv6, as long as they're of the minimum size. We also support adding those CIDR blocks to existing connections. So in this case, what we do is we need to see if one's already been added. So when you look at your list of transit gateways in the console, if you go to the gear icon, the settings icon in the top right, you can show hide columns, and you can choose to show the transit gateway CIDR blocks, and that will show if any have been assigned. If not, you can go to Actions, Modify, and then you can modify your transit gateway to add the CIDR blocks to an existing transit gateway. So once we've done that, we can then look at creating a Connect attachment. So here we've chosen the transit gateway. We're choosing to create a Connect attachment type. So this is the new Connect type for Transit Gateway Connect. We give it a name tag, and then we choose the transport attachment ID that the Connect attachment will run over. So in this case, we've chosen a typical VPC attachment. We select that, and we click Create Attachment. And within a few seconds, we will then have the Connect attachment appear in the list of attachments. You notice we have two, so we have the VPC attachment and the Connect attachment. If we select the Connect attachment, we can then view the Connect Peers tab as highlighted on the screen. And at the moment, we have no Connect Peers established. What we can do is we can choose to create one. And then this will give us a simple wizard to create this. So again, it will pre-populate the gateway ID and the Connect attachment ID. We give it a name tag. We choose an IP address from the Transit Gateway CIDR block. So in this case, 10.10.10.1. We give it the peer address. So this will be the address of the network virtual appliance, 172.16.0.20. And we define the BGP inside CIDR blocks that will be used to exchange the routing information. Once we've done that, we can click Create, and then that peer will be established between the network virtual appliance and Transit Gateway. So that's a simple walkthrough on how to deploy Transit Gateway Connect. It's worth pointing out, of course, that many of our customers will have an existing architecture, an existing solution, either using Transit VPC or Transit Gateway. And so we've designed Transit Gateway Connect to be really easy to adopt. It's designed so that they can coexist. It can coexist with a Transit VPC or a Transit Gateway architecture. So it's possible to run both in parallel. And then we can enable an easy migration between the existing solution and Transit Gateway Connect without service interruptions, simply by updating the routes, the appropriate routes. This means we can test, we can fail over, we can fail back as needed, simply by making those route table changes. So that's how to do it in terms of using Transit Gateway within the console, Transit Gateway Connect within the console. But what we also want to do is highlight the fact we have a number of launch partners who are aiming to integrate this into their SD-WAN solution, and therefore will make the overall solution far easier to deploy and deliver and make it a part of their solution. So I'm pleased to say we have 13 partners at launch, and we expect to add more later. You can see some of the names there, some of the key network players in the space. And these partners will provide both simple deployment and scaling options for SD-WAN and core network connectivity. What I'd like to do now is just take a look at a couple of those services. So we'll start with Aruba. And what we find with Aruba is this is the walkthrough on how to make the AWS infrastructure part of their SD-WAN environment. And it's a three-stage process. We start by discovering the cloud environment. Then we orchestrate the Transit Gateway Connect infrastructure. And then we connect the Aruba virtual gateways into our Transit Gateway architecture. And at that stage, we have an end-to-end cloud to SD-WAN architecture. And this is really simple. So there's a wizard interface within the Aruba console. You can choose the console, the regions, the VPCs. You can identify the transit gateways you wish to use. You can then orchestrate that Transit Gateway Connect infrastructure. So this will create the Edge VPC, or the Connect VPC as we called it. It will establish any attachments needed to the Transit Gateway, create the security groups needed. It will launch the Aruba virtual gateways from the AWS Marketplace. And then finally, we can orchestrate the connection of those virtual appliances into Transit Gateway. We orchestrate the GRE tunnels, so the connect peers. We create the BGP peering. And then we have, at the end, effectively an end-to-end cloud to SD-WAN architecture. The really nice thing about this is that this is also easy to visualize, both within the Aruba console, but also within the AWS Network Manager console. So we can get to visualize everything from the branch network all the way through to the SD-WAN appliances and then the spoke VPCs. Next, Cisco. So again, Cisco provide the ability to integrate through their console. In this case, we choose a cloud gateway, and we choose the type AWS Transit Gateway Connect. We then go on to configure things like the instance size that will be used for the virtual appliances, the VPC. We then complete the configuration, and if we look at the diagram on the right, we can see we've got the branch services, the SD-WAN architectures. We have the tunnel VPC, the transit VPC that hosts those instances. Then we establish a GRE tunnel into Transit Gateway, and then from Transit Gateway to those hub VPC, those spoke VPCs. So now we have an orchestrated end-to-end SD-WAN solution. And again, this gives us the ability to use some of the Cisco capabilities to establish granular source destination connectivity. So between particular sources, maybe you want particular sources to only connect to a certain number of VPCs. That's all configurable within the SD-WAN solution. So that's a look at the partners. We'll just go a little bit more now into some implementation details. We'll start with the routing because this is core. So a key thing to call out is that Transit Gateway Connect supports BGP only. So we don't support static routing between the SD-WAN appliance and Transit Gateway Connect. However, it's worth pointing out that internal BGP, exterior BGP, and multi-protocol BGP are all supported. And the reason we do this is so that the routes will be dynamically propagated from the SD-WAN appliances into the Transit Gateway route tables. It's worth pointing out at this point that those routes aren't propagated into the VPCs themselves, so the spoke VPCs themselves. You still need to do that through your VPC configuration, and you will typically announce summary routes back to the Transit Gateway. Those connect attachments are granular, so they can be used to deliver routing segmentation. You may choose to have different connect attachments that can connect to different spokes on your architecture. And we also support equal cost multipathing. So this means that we can scale out our architecture across multiple connect peers. So we can do this for scalability and also for high availability. So we can now have multiple virtual appliances connected using ECMP into this Transit Gateway Connect architecture. So this gives us the ability to have highly scalable, highly resilient SD-WAN connectivity using Transit Gateway Connect. In terms of performance, so we will look at transport attachments to start with. So we have Transit Gateway VPC. So this is the one type of attachment. We have the VPC attachments. These can burst up to 50 gigabits per second, the same as any VPC attachment. And so because Transit Gateway Connect runs on top of this, it will be able to utilize up to the maximum available on the Transit Gateway VPC attachment. We also support direct connect attachments. So the throughput will be dependent on the size of the DX connection. If you have multiple 10 gig connections in a lag group, then you will be able to make use of the size of that as needed. So once we've established those transport attachments, so the VPC or the direct connect attachments, we then create the connect attachment. And for each connect attachment, we can create a connect peer, which can burst up to 5 gigabits per second. So that connect peer is a GRE tunnel, and that can burst up to a 5 gigabits per second throughput. But each connect attachment can support up to 4 connect peers. And so using ECMP, we can actually burst up to 20 gigabits per second. And if we need to go beyond that, we can have multiple connect attachments, and each of those connect attachments are supported. Multiple connect attachments are supported per transport attachment. So you could see you have maybe 2 connect attachments over a VPC attachment. You can get up to 40 gigabits per second using that configuration. We also support 1,000 inbound route announcements and 100 outbound route announcements per connect peer, and we expect to iterate and improve on this over time. From a monitoring and management perspective, as you might expect, we emit a number of CloudWatch metrics, including for bytes in, out, and dropped, packets in, out, and dropped, and also for information around the connect peer itself. So the BGP peer status and how many prefixes have been sent and received over that BGP interface. Equally as importantly, we integrate with CloudWatch events, Amazon CloudWatch events. This enables us to emit events when we see certain events take place within Transit Gateway Connect. So as an example, whenever we see a Connect attachment created, we can emit an event. If we see a Connect peer created, we can emit an event. And when we see a BGP state change or prefix advertised or withdrawn, we can emit CloudWatch events. This means that you can build, or partners can build, automated integrations that say that when we see a scaling event or when we add a Connect peer, we can make the appropriate changes to the rest of our infrastructure to support that. CloudFormation support is coming soon. Pricing and availability. So the pricing is based on pricing in US East 1. So a Transit Gateway Connect attachment will cost 5 cents per hour. It will require, obviously, the underlying VPC attachment or direct connect attachment. So there will be a cost there as well. But it's worth calling out that there is potential for large savings compared to our previous architectures, because this architecture removes the need for that AWS site-to-site VPN connection from those SD-WAN appliances into the Transit Gateway. So when you consider that a site-to-site VPN typically has a throughput of about 1.2 gigabits per second, and new GRE tunnels, the connect attachments, can handle 5 gigabits per second, you can see that we can get 4 times the performance for the same price as a single site-to-site VPN. So we offer up 4 times performance for the same price. In terms of region availability at launch, we've launched in US East 1, US West 1, US West 2, and EU West 1. And we expect other services to, other regions to launch as customer demand dictates. So really, just to summarize this capability, so AWS Transit Gateway Connect is really designed around 4 key values. So We want it to be simple. It natively integrates with Transit Gateway without the need for those complex IPsec VPN connections. And it's designed very much to be automated and integrated with partner solutions. By using GRE tunnels over those native VPC attachments, we can get around 4 times the bandwidth throughput with lower overhead compared to the IPsec site-to-site VPNs that are used by existing solutions. Because we're building on top of Transit Gateway Connect, on top of Transit Gateway, we get the benefits of the scale, the performance, the high availability that Transit Gateway offers. And we can overcome some of the route limitations that are encountered across existing solutions, and also some of the performance issues around existing solutions. And because of our integration with things like AWS Network Manager and third-party solutions, SD-WAN solutions, we get high visibility into the way this branch network is configured, the way the SD-WAN cloud is configured, and also visibility into those performance metrics and telemetry data. So with that, I'd like to say thank you very much for listening. I'd encourage you to go out, log on to the console, look at the solutions we have, visit some of the partners, look at the marketplace, and try some of these things out. Thanks for your time, and please remember to complete the survey. Thank you.